This is Kisembo Academy and thanks for tuning in. Today we get to look at simplifying algebraic expressions by collecting like terms. Now before we get to simplify these algebraic expressions, we need to explore and ask ourselves, what exactly is an algebraic term? Now, an algebraic term may be a number, a letter, or both, which both represent a particular phrase in a statement. For example, on our screen we are looking at algebraic expressions. This is an algebraic expression. This is also an algebraic expression. So now, when we talk about an algebraic term, we are simply talking about this 2x, this 3y, and this 4z. These are what we are calling algebraic terms, and these algebraic terms are being separated by either an equals. They are separated by either a plus sign or a minus sign. They are either an algebraic term is they are separated by either a plus or a minus sign. Likewise, even here, this is an algebraic term. That is a term. That is a term. That is a term. So if you look at this algebraic expression, it's having 3 terms. This algebraic expression, it's having 1, 2, 3, 4 terms, and we say that algebraic terms are separated by either a plus or a minus sign. Now, knowing that these are what we call terms, then we ask ourselves, what do we mean when we say we are collecting like terms and we are collecting unlike terms? Now, like terms are those which have the same variable, or call it the same unknown. If you have a look at this, we're having this algebraic term 2x plus 3x plus 4x. Now you realize that they're all having x. They are having the same variable or the same unknown. So because they're having the same unknown, we call them like terms. Likewise, if we're having, on the other hand, if you're having an algebraic expression that is having different terms, for different variables, for example, here this 2 has x, this is y, this is z. These are 3 different variables. So these terms are unlike terms. So in this video, we shall be looking at how to solve algebraic expressions by collecting like terms. It is always the first step. We always first collect like terms, then we go ahead and find the value of the variable in the algebraic expression. We shall do a few examples. Let's collect like terms and simplify this algebraic expression. Here we are having 2a plus 3a minus 4a. All these are a's, so they are like terms. So they are already collected as like terms. So to simplify it further would be 2a plus 3a is going to be 5a minus 4a. And of course our answer here is going to be a. 5a minus 4a is a. So we have collected like terms and simplified it. Getting to the next. We're having this collecting like terms here. We're having x squared and x squared. So it means that these 2 terms, this and these are like. This one is only having x, so it is unlike. So collecting like terms is going to be 3x squared plus 2x squared is going to give us 5x squared plus 4x. So we've collected like terms and it is already simplified. Next, we're looking at this algebraic expression. We have p squared q, we have p squared q, we have p, then we have qp. If you realize here, looking at the unknowns, you realize that this term and that term are like terms because they are having the same bunch of unknowns. But this 2p and this qp, these 2 are unlike. They do not resemble this. So we only add terms that are like. So if this is p squared q plus p squared q, this is 4 plus 3. That is going to give us 7p squared q. Then this is minus 2p plus 3qp. So we have added the like terms, and that is how far. We can't go any further than this. Same as here, we have 4m cubed and here 6m cubed. This term and that term are like terms. Then this is 5m, it's on its own, and 4y is different from the rest. So to collect like terms here means that it's going to become 4m cubed. Collect this is 6m, so it is going to be minus 6m, so it's minus 6m cubed, then plus 5m plus 4y. Then for 4m cubed minus this, since these are like terms, they are compatible. 4 minus 6 is going to give us minus 2m cubed plus 5m plus 4y. And that's how we collect like terms. This brings us to the end of this video. Up next, we shall be doing more of this. For more videos, please remember to subscribe. This is Anu Rangakuramia on behalf of Kisembo Academy.